A part 1. Okay, so we have V equals V0 E minus T over RC. I put log on both sides. Log V equals log V0 E minus T over RC. So I get log V equals log V0 plus log E minus T over RC. So I get log V equals log V0 minus T over RC. So I get log V equals minus 1 over RC times T plus log V0. So if you compare it, Y equals mx plus c, you can see that the slope represents minus 1 over RC, which is what they say to do in the question. So 2 marks there for that. Okay, did you write that down? So let's have a look at the... Yes? Yes. Well, let's have a look at the next part then. In the circuit shown below, with both switches A and B closed, so now closed, the 5 microfarad capacitor is charged to a potential difference of 12 volts and a current flows through R1 only, since R2 is broken. When switch A is then open, the capacitor begins to discharge through R1. The value of potential difference across the capacitors are recorded against time as shown in the table below. After 30 seconds, when switch B is open, so that the capacitor then discharges through R1 and R2 in series. After 30 seconds. So what they're saying here is, you see the capacitor in the middle? That's fully charged. And then what they do is they open switch A. So when they open switch A, the battery is removed. So then what happens with the capacitor? It starts to discharge. It discharges through R1. And then 30 seconds later, they close the second switch, and then it discharges through R1 and R2. So basically, the resistance is increased after 30 seconds. They give us this table, and they want you just to write in log V. And you have V as 12, so just put in log 12, log 9.82, log 8.04, and so on. So can you write those log values in? Then on graph paper, draw the graph of potential difference and time. Okay. Okay, so we want to have, I'll put in the 2 values here, V and then T. So the voltages are 12, 9.82, 8.04, 6.59, 6.59, 6.33. Oh, thank you. 6.59, 6.33, 6.08, 5.85, and then 5.62. And we would like to have log v. So that is log of this number. Now, I don't know if this is...
It's not log, it's ln.
Yeah, but on Excel, I think log is actually ln, but I'll write in the base 2.71828, roughly. So did you get about roughly 2.4?
2.4, yeah.
Yeah, okay. So here are all the logs. Great. And then the times are in 10 seconds. Yeah, 0, 10, 20, 30, 40, 50, 60, 70. Okay. Now we want to graph it. Potential difference against time. So v on the y-axis and time on the x-axis. Okay, so we would like a graph of this. T on the x-axis, v on the y-axis. So insert, chart, this one, next, get rid of that, my graph. X-axis is time in seconds and y-axis is v in v, and there we go. So, yes, it's quite amazing. Let me just make it a bit smaller. Focus. Now, we have the graph. Plot the graph of potential difference against time. So how many marks for that graph? 8 marks.
Yeah.
Okay. Find the value of the gradients of the two straight parts of the graph with their appropriate units. So what's happened here is you can't quite see, well, you can kind of see it on this graph, but there's actually 2 lines. First line goes down, and then they increase the resistor, and then you have a second line.
Which is also going down.
Which is also going down. And what did they ask for? The gradient, is it?
Both of them.
For both of them.
So how would I comment on the graph?
Oh, they asked for a comment?
No, I'm just...
Oh, if they did, what they'd be looking for is the change at 30 seconds in the gradient.
Oh.
That's the key thing there. Okay. Hence the term of... Yes, okay. Now, I think, if you look at the question, I think they made a mistake in the question. I think they said, or they meant to say, plot log v against time. But what did they say in the question? Potential difference. Because this isn't really a straight line, it's exponential. So I'll just redo this graph with log v. I suspect that's what they want. I'll check the marking scheme, okay? So if I just do this one again, but with log v. After all, why did they bother to ask us to calculate log v if we weren't going to use it in the graph? Okay, so let me just take my values here instead. Log v, guys, just look up. Okay, so insert chart.
Log v should be on the y-axis.
Yeah, it's the right way around, and time's on the x-axis. Okay, on the x-axis is time in seconds, and on the y-axis is log v in log volt units. Show me both, give me title, my graph, finish. Okay. A little bit better. It's almost the same. Okay, let's try and just use our eyesight here to get the two slopes. So for the first one, it starts at 2.5 and then it decreases to roughly about 1.8.
Yeah.
So 2.5 minus 1.8. Let's write that down.
So R is supposed to be a straight line.
It is a straight line. One straight line and another straight line.
No, like one straight.
No,
No,
we increase the resistance, which makes the
changes the slope. Okay, so what did we say? M equals 2.5 minus
0.5.
1.8.
Oh, 1.5.
Yeah. Over 30. Okay, what's this, please? And it's a minus because it's going down.
It is 0.2, 0.023.
0.023 minus.
Minus.
Yeah.
Now, don't forget, what's our formula for n? What does n represent? Minus 1 over RC equals minus 0.023. So you could work out what the OR is. The OR equals 1 over 0.023 multiplied the C, which they give us as 5 micro. So what does this equal, please?
It's 869.
8.6.
8.7 times 10 to the power 6.
I disagree with this.
Why can't we just use our calculators, right?
8.57 times 10 to the power 6.
Oh,
Yeah, that's what I got.
Which is different.
let's see. Eight, 6, 9, 5, 6, 5, 2. Yeah. 8.6 times 10 to the 6.
Yes.
8.7 times 10 to the 6. Okay, now let's look at the next one. So what it's we might have to zoom in a bit here to try and get the next one. Oh yeah. Right. About 1.8 to 1.5. So how big is that? 0.3.
No, it's 7.5.
What do you think? 1. From 1.8 about?
Yeah, but where did you get that from?
Oh, sorry, this is 1.5. Oh, so maybe it's more like 1.9 and then 1.6. So we'll say about,
No.
let's just say about 0.25. It looks about a quarter. If this is a half, then yeah, about a quarter. 0.25 divided by how many seconds? 40 seconds. From here to here is 40 seconds.
6.25 times 10 to minus 3.
That's what it is?
Yeah.
With minus.
Okay, so for the other one you got m equals with a minus 6 point
25 times 10 to minus
10 to the minus
3.
3. Okay, and once again we can get our OR as 1 over 6.25 times 10 to the minus 3 times 5 times 10 to the minus 6. So
3, 32 megawatt.
32 times 10 to
Yeah,
6.
32 times
32 times
10 to 6.
10 to the 6. That's the OR. Now, is that what OR1 and OR2? Is that what OR1 and OR2 both equal? Is that OR1 and OR2? No. The first answer is OR1, but why is that not OR2?
Because we're 2 resistors.
Because that's the total resistance. So we need to find OR2 now.
That one from the
No? Are they in series or parallel? Oh, yeah. Subtract one from another. So if I subtract these, what do I get? The OR1 is 8.7 times 10 to the 6.
You get 23.3 times 10 to 6.
And then OR2, if I subtract, what is it, 20?
23.3 times 10 to 6.
So in other words, 8.7 mega ohms and then 23.3 mega ohms.
Can I know why did you like subtract?
Because two resistors are in series.
He's telling you. Turn to him.
Look at the picture.
Look.
There are two resistors.
The-
The first part of the graph that we solved is for the one resistor R1.
Mm-hmm.
Then we solved the second one, which is for both of them. So we have total resistance R1 plus R2. To find R2, we have to subtract the second result, the first result from second.
Yeah. And then that's a finish, isn't it? Yeah, 20 marks. So let me just see how accurate we were. I would be amazed if we were close to the answer because we didn't do this on proper graph paper. We just judged by our eye. What did we get for R1?
8.7.
Yeah. And then for R2? Okay. It's not too bad. I mean, we were just looking with our eyes. So they're, close. It wasn't like I got 500 mega ohms. Ours were very much approximations because if you were doing this in the exam, you should measure exactly. But you can see, even just using our eyes, close enough. Not too difficult, okay? Right. So, it looks like from that book, the ones we've done, can I just tick them off the back here?